Now that we have been introduced to modular arithmetic, demonstrating clock arithmetic using the division algorithm, we see that it is the remainder that is the integer we are trying to determine. And that is what modular arithmetic is about. It can be thought of as the arithmetic of remainders. So now that we have this special process, we have a special notation. And that notation is right here, A modulo n. This mod, M-O-D, it's actually pronounced as modulo. Sometimes you'll hear me say A modulo n. Sometimes you'll just hear me shorthanded as A mod n, but it's actually pronounced modulo. And what this is this is a remainder. So if we know from our division algorithm A is equal to Q times B plus R, we can now say that our remainder here is equal to A mod n. So I'm going to say our remainder is equal to A mod n. So for these problems here, A through F here, we have this 15 modulo 4. 15 we typically know as the dividend, and 4 we typically know as the divisor. We can now give it the name the modulus. So we can think of as 4 as the modulus here, 33 is the modulus, but it's actually the divisor. So what this means is that 15 modulo 4 means what is the remainder when I take 15 and I divide it by 4. So I'm going to put A right here, 15 modulo 4. Using the division algorithm, we'll have 15. That's going to be equal to our quotient will be 3 times 4. That's 12 plus 3, and here's our remainder. So since our remainder is 3, we can say that 15 mod 4 is equal to 3. That's a remainder. We'll do the same for B. We have 267 modulo 33. Using the division algorithm, I have 267. And I'm going to use my calculator. We have 267. I'm going to divide that by 33. That gives us 8. Don't forget, we always round this down to the nearest integer. So this is going to be 8 times 33. And 8 times 33 is 264. So then I'll add 3 more. So 267 is equal to 8 times 33 plus 3. That's our remainder. So we could say that 267 mod 33 is 3. Here's C. Now sometimes for some of these, you should get in the habit or an idea of what's going on. We have 121 modulo 10. So that means what would be the remainder if I divide 10 into 121? So I'm just going to take a guess and say that that would be 1, right? But if we go ahead and we use our division algorithm, I've got 121. That's going to be equal to 12 times 10, which is 120, plus 1. And there we go. For D, negative 53 modulo 5, negative 53 mod 5, negative 53, divide that by 5. Don't forget we're going to round that down to the nearest integer. So using the division algorithm, we're going to have negative 53. It's going to be equal to negative 11 times 5. Negative 11 times 5, that's negative 55, plus 2 is going to give us negative 53. So the remainder is 2. So negative 53 mod 5 is 2. Let's try E. negative 1,275 modulo 23, negative 1,275, divide that by 23. That gives us negative 55. Again, we're going to round that down to negative 56. So using the division algorithm, we're going to have negative 1,275. It's going to be equal to negative 56 times 23. And negative 56 times 23. That's negative 1,288. So if I add 13 more, negative 1,275, that's equal to negative 56 times 23 plus 13. So that's the remainder, the 13. So negative 1,275 modulus 23 is 13. And finally for F, 228 mod 19, we have 228 using the division algorithm. 228 divided by 19, that's 12. So this is then 12 times 19 plus 0, because 12 times 19 equals 228 with a remainder of 0. So we can say that 228 modulo 19 is 0. That could also be stated that 19 is a divisor of 228. But there we go.